can go over them. Then pressure. Whenever you are increasing pressure of a reactant, you are decreasing the concentration, and that will lead to increase in the rate of the reaction. Then we have here light. We have some reaction that can only occur in the presence of light. Such reaction will not occur in the dark. For instance, the reaction between hydrogen and chlorine will be faster when they are being exposed to sunlight. Then, apart from that, we have the decomposition of hydrogen peroxide. It's also catalyzed by the presence of light. I will discuss a lot on that, and I told you that that kind of reaction is like a substitution reaction. If you look at the one we did between your chlorine, hydrogen chloride, and methane, I want to believe you have that in your notes. The reaction between chlorine and methane, which is a substitution reaction. So these are the factors affecting the rate of reaction. Remember I said I want to dwell on the temperature, the concentration, and the pressure. So I've told you, when you increase temperature, you are increasing the heat content, and thereby the reactant will gain enough kinetic energy to overcome the energy barrier. They will have enough energy to break away from the bond holding them together, and then that will lead to a faster rate of reaction. And then concentration. I said when you increase the concentration of the reactant, you are increasing the molecule, and then indirectly you are increasing the rate of pollution, and that will also lead to a faster rate of reaction. Then pressure too. When you increase pressure, you are decreasing concentration. So as you are increasing pressure, definitely there will be increase in collision, and then that will also lead to increase in rate of reaction. So that is that about the rate of reaction. Now, to chemical equilibrium, we have the first one, temperature. If you want to explain the rate at which temperature affects chemical equilibrium, you must look at the reaction. If they write the reaction, you can see probably I have something like A plus B to give me C plus D. Then there will be something here. They will write something like delta H. Remember, your delta H means change in heat content. And here you will see something like probably delta H equals to probably, let me just say, minus 10 kilojoule per mole. Then you can see at times it can be positive too. Now, first thing you have to do, if you are asked to explain the effect of temperature on such reaction, now you have to look at the change in heat content. From the change in heat content, deduce if the reaction is exothermic or the reaction is endothermic. If the change in heat is negative, then it means it is exothermic. If change in heat is positive, then it means it is endothermic. That is the first thing you must know. Then the second one now is this. If the reaction is exothermic, if the reaction is exothermic reaction, then it simply means that the reaction does not require much heat to proceed. So such reaction needs reduced temperature. So when a reaction is exothermic, if you are now asked the effect of decrease in temperature, decrease in temperature will shift the equilibrium position to the right. If you shift the equilibrium position to the right, that is, decrease in temperature of an exothermic reaction will favor forward reaction. If it favors forward reaction, you can say favor forward reaction or shift the equilibrium position to the right. But if it is increased, I told you exothermic need reduce temperature. So if they are now increasing the temperature, you know that will work negatively because the reaction requires reduced temperature. But now they are now increasing the temperature. What will happen? It will shift the equilibrium position to the back. That is, to shift the equilibrium position to the left, thereby favoring the backward reaction. So, if a reaction is exothermic, increase in pressure will favor forward reaction. That is, it will shift the equilibrium position to the right. That is for decrease. But if you increase the temperature, it will change the equilibrium position to the left. That is, it will favor the backward reaction. So that is the effect of temperature on exothermic reaction. But if the reaction is endothermic, reaction, now endothermic needs enough temperature. So for endothermic reaction, if you increase the temperature, it will shift the equilibrium position to the right. That is, it will favor forward reaction. But if you decrease the temperature, then the reverse will be the case. That is, if you decrease the temperature of an endothermic reaction, it will shift the equilibrium position to the left. That is, it will favor the backward reaction. So endothermic reaction needs increased pressure to move forward. So if you increase the pressure, it will favor forward reaction. If you decrease the pressure, it will favor backward reaction. So that's about temperature. I told you the first thing to do, look at the equation. From the equation, the change in heat content, is it endothermic or is it exothermic? Then it is from there you cannot deduce what will be the effect of the temperature. Then we have concentration. Now, in concentration, when you have a reactant, just like the equation I have on the board here, if you are increasing the concentration of the reactant, the equilibrium position will shift to the right. That is, it will favor forward reaction. But if you reduce the temperature, then it will favor backward reaction. So if you look at it, A plus B, so give me this C plus D. Then, if I should increase the concentration of A, it favors forward reaction. If I reduce the concentration of A, then it will favor backward reaction. At the same time, if I increase the concentration of B, it will still favor forward reaction. If I reduce the concentration of this B, then it will favor backward reaction. Then apart from that, if you increase the concentration of the product, it will favor backward reaction. But if you are removing the product as they are being formed, then more product will be formed. It's just like you want to fetch water and you are holding probably this bottled water, this normal 50 cl bottled water, and you are collecting water from a very big tank, probably 2,000 liters. You will note that once that small 50 cl bottle is filled up, you will not be able to collect more water. But if you have more water, as that bottle is being filled up, if you are pouring it to another bucket, then you'll be able to collect more water. That is exactly what I'm trying to explain to you here. So as this C and D, the product are being formed, if you are removing from the product, you are removing part of them, then more product will be formed. So that means removing from this C and D here will lead to will make the equilibrium position to shift to the right, or we favor forward reaction. That is the effect of concentration.